Okay, in the first question, they have given us eosin. I have a one molecule of eosin, and the molar mass, the weight of that one molecule of eosin is going to be 692 U, I can say, or 1 mole of eosin will weight 692 gram per 1 mole. Anyway, so they are given this compound is a component of a red ink. If Sarvajit is written by red ink, it weighs this much gram. So I know 1 mole of eosin will have the weight of this, and they are given the weight of eosin as 1.73 into 10 power minus 10 gram. So how many moles it will have? So you have to find the moles. Just pick this side, or else you can find moles is equal to given mass divided by molar mass. So given mass is 1.73 into 10 power minus 10 divided by 692 gram. This is also gram per mole. So gram get cancelled. The final answer you will get is 0.25 into 10 power minus 12. Okay. Now Kaushik is written by graphite pencil and it weighs this much gram. What is graphite? So graphite is made up of carbon particles, right? Carbon atoms, let's say. So let's see the moles of graphite particles, which is nothing but I'm going to calculate the carbon atoms, will be equal to how much it has 3 into 10 power minus 12 gram, and the carbon atom will weigh 12 gram per 1 mole of carbon. So again, if you solve this, it will come as 0.25 into 10 power minus 12 mole. This is mole. So you can see both are in the equal amount, eosin and graphite, so that you can eliminate these two options directly. Eosin particle are more than the graphite particle? No, it is equal. Graphite particle are greater than the eosin particle? No, it is equal. And what about the mole percentage? How to calculate the mole percentage? So mole percentage of what? Bromine, right? In eosin. So for calculating the mole percentage, what I have to do is I have to calculate how many moles of bromine are there. So I can say moles of bromine divided by total moles of all atoms into 100, right? So I can say this is for 1 mole of eosin. So I'm calculating the percentage. Per mole of eosin, how much, how many percent that are moles of Br is there, right? So what I have to do is, how many bromines are there? You can see here, bromine, 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 bromine. So 4 bromines, I can write it here, 4 bromines. And what about other atoms? Let's say carbon. So how many carbons are there? Each end is a carbon, right? So I can say this is a benzene ring, or you can say cyclohexane. So here it is a benzene ring because it is having alternative double bonds also. So here I have 6 carbon, and here I have 6 carbon. This 2 carbon I already counted, and then I am counting these 3 carbon. 1, 2, 3. So 3. And here I have 1, 2, 3, 4 carbon. So how many carbons are there total? and here one carbon. So 6 plus 6, 6 plus 6, 12, 12 plus 3, 15, 19, 20. So the total number of carbon atom is 20. And what about other atoms? Let's take Na. Na is 2. So I can write Na2. And bromine is 4, already calculated. What about oxygen? Here 2 oxygen, 3, 4, 5. So oxygen is about 5. And what about hydrogen? We have hydrogen here, right? So how many hydrogens are there total? Here one hydrogen. We know that carbon is going to have 1, 2, 3 bonds only, but it should have the fourth bond. That fourth bond belongs to the bond between carbon and hydrogen, right? So you will have carbon, hydrogen over here. And here one hydrogen, here one hydrogen. Here already 1, 2, 3, 4 carbon. Bonds are satisfied. Here one, here you can see 4 bonds are satisfied. And here one, here one. So total it was 1, 2, 3, 4, 5, 6. So hydrogen atoms are 6 atoms. So I have 20 carbon atoms, 6 hydrogen atoms, 4 bromine atoms, 2 Na like sodium atoms, and 5 oxygen atoms. So this is the total number of, right? Into 100. If you calculate this, you will get the answer as 10.8. This 10.8 is a percentage, is a mole percentage of bromine. Okay. So the given option C is going to be the right answer. What about the mass percentage of bromine? Let's see. The mass of bromine is 80 almost gram per mole for bromine. Per mole, it will weigh 80 gram. Now 4 bromines are there. So total number of bromines and total weight of bromine, all 4 atoms of bromine is going to be 4 in 80. Divided by total mass of the compound is given as 692 into 100. If you do this, you will get around 0.4624 into 100 again. So it will be around 46.24. It is not 2.5. So the mass percentage of bromine is 46.24. So this is not going to be your answer. So answer is going to be C. And the next question is quite easy question. So you have an compound. This is called propane. How do you identify this as a propane? It follows the molecular formula of CnH2n plus 2. If n is equal to 3, then how many hydrogen atoms should be attached to all these carbon? So 2 into 3, 6. So 6 plus 2, 8, right? The whole value. So C3H8. It is going to react with 5 moles of O2. So hydrocarbon is reacting with oxygen. When you ignite it at that ignition temperature, we call this reaction as combustion reaction, reaction with oxygen. So you can eliminate, there is only one combustion reaction. So answer is going to be C. Directly you can answer this. Let's see other things. Then I'm getting 3 moles of CO2 and 4H2. Now what is happening to this propane? Propane is getting converted into CO2. So addition of oxygen, I can say directly. So addition of oxygen, it is going to be, I can say carbon is oxidized, right? What about oxygen? Here it is in zero oxidation state. but here it is in -2 oxidation state by getting electron from carbon. So 0 O2 to O2 minus 0 oxidations to 2 minus, it is gained 2 electrons. So I can say oxygen is reduced. So both are taking place, right? Reduction and oxygen. So this reaction can be called it as redox reaction. So answer is going to be C. And this one. Now again I have an reaction 2KOH plus H2. Here what is happening here? What is happening to potassium first? Potassium is in metallic state, which means it has an oxidation state of 0. It is getting converted into K plus ion. So K to K plus 1, which means I am removing one electron. So I can call this as oxidation, or I can say from this I can say K is getting oxidized. K is nothing but potassium. Okay. Now again come to hydrogen. Here hydrogen is with the oxygen. Oxygen is more electronegative, which means it need electron more. It will attract the electron from hydrogen, hydrogen's electron. So I can say hydrogen is in +1 oxidation state because hydrogen has only one electron. Oxygen is going to get one electron from one hydrogen. And here molecular form, it is going to have 0. So it is getting from H plus to H2, where it is turning from +1 to 0 by getting an electron. Then I can call this as reduction, right? Or I can say hydrogen H plus is getting, or hydrogen, let's say, reduced. Then these two options are correct. It is a displacement reaction. Yeah, it is a displacement reaction. How can I define a displacement reaction? Here, what is happening? This is an water. This is K. What is happening in between them? This hydrogen was replaced by this K, right? So I can say, or I can say H plus is displaced by K plus. So this is also correct one. And it is not a neutralization reaction because what is happening here? Oxidation and reduction. It is going to be a redox reaction. Neutralization reaction doesn't not involve any oxidation or reduction. Let's say I have KOH, which is a base, and I have acid. Let's see their charges. So again, it will form KCl plus H2O. I'm writing it as HOH. So you can see their charges are not changed. Their charges are remain same, right? So answer is going to be D, because they are asking for not true. Next question is assumption and reason. Assumption: after whitewashing the wall, a shiny white finish on wall is obtained after 2 to 3 days. Yes, this is correct actually. We will get a shiny after all water molecules are getting evaporated from that compound, right? I will tell you the reaction first. Calcium oxide reacts with carbon dioxide to form calcium hydrogen carbonate. Actually, what is, let's say this is going to be a limestone calcium carbonate, and we are going to heat it. Are going to heat it. So if you are heating this, the carbon dioxide will escape from this compound. So you will get CaO. When you are dissolving this in water, you will get CaOH twice. So this we call it as slaked lime or lime water. And this one is called as quicklime. And this is what we are using for whitewashing. So what happens when you paint it on a wall? Let's consider this is a wall. You are going to paint it with a calcium oxide. Sorry, slake lime. You are going to paint it here. So now in atmosphere you have CO2, right? And this CO2 again tries to combine with this slaked lime to become CaCO3 plus water molecule. The layer that is formed when slaked lime is exposed to CO2 environment, that is converted into CaCO3, and this gives the shiny layer. Okay, so answer is going to be calcium carbonate, not calcium hydrogen carbonate. The shiny white finish is due to CaCO3, and it is not calcium oxide, it is calcium hydroxide. Sometimes what will happen, this water is getting evaporated faster so that it will again convert into CaO, and then it is CO2 will be reacting with CaO, it will form CaCO3 again. So answer is going to be, assertion is true, but R is going to be false. So answer is C. In this question, we have given with a reaction MnO2 plus 4HCl molecule. It is going to convert into MnCl2 plus 2H2O plus Cl2. So what is happening here? Mn here, X plus 2 oxygens are there. For 2 oxygen, oxidation state is going to be -2. So Mn is in +4 oxidation state here, and Cl is in -1 oxidation state here. Here Cl is in 0 oxidation state. Here Mn is in +2 oxidation state. So what has happened here? Mn is converted into +4 to +2. So I can say Mn is getting reduced. So Mn 4 plus 2, Mn 2 plus by gaining 2 electron, which means Mn is getting reduced. That means it is taking electron from, let's say, chlorine, means it's oxidizing the chlorine molecule, right? It is getting reduced and acting as a oxidizing agent. So from here, I can say directly that MnO2 is reduced to MnCl2. Yeah, it is right. And MnO2 is acting as an oxidizing agent. Yeah, it is also right. And what about the first one? So you have HCl minus, and it is going to get 0. -1 to 0. How it is? Cl minus is getting oxidized, right? How? Cl minus is there, it is getting converted into Cl2, which is in 0 oxidation state. Let's say 2. Which means I have removed 2 electrons from 2Cl minus to become one molecule of Cl2. So it is an reaction of belongs to oxidation. It is undergoing oxidation Cl minus. Then I can say it is acting as a reducing agent. So this is wrong, but Cl minus is oxidized. So 1, 2, 3. All three, or I mean 1, 2, 3 statements are correct. So option B is going to be the correct answer. Okay, next. Which of the following is true for the given nuclear reaction? So the given reaction is thorium 228 mass number and it has 90 protons. It is going to convert into bismuth 212 and 83. Let's see. The total of 4 alpha and 1 beta particle are emitted per nucleus. What is alpha particle? Alpha particle is nothing but 2 proton and 2 neutron, I can say. It is a helium molecule. In helium molecule, what else you have? You have 2 protons and you have 2 proton and 4 neutron and you have electron also. But you are going to remove those 2 electrons so that it will get helium 2 plus ion. Where? Let's say this is our 2 proton, this is 2 neutron, and this is the electron, 2 electron. Now you are removing these 2 electrons so that you are getting the nucleus of a helium atom. That nucleus of a helium atom is called alpha particle. So alpha particle I can write, it has 2 proton and 2 neutrons so that mass number will become 4. They are saying the total of 4 alpha particle are emitted. Let's see. So I can write this reaction as again 212 plus 83. How much change it is happening to the mass number? Around 16, right? So they are saying 4 alpha particle. The mass number is changed by 16. So if I write 4 alpha particle here, it can balance this. If you add this, you will get this. It can balance this, mass number, right? So what about beta particle? They mentioned about beta particle also, right? Okay, see here, this is 83 and you have 4 2s are 8. 83 plus 8 is 91, right? So you should have a 91 here, but the thorium nucleus have 90 protons. But here 91, how it is possible? So then you should include one beta particle. So beta particle will -1, you have to add. So what else? Now you will get what? -1, 90. It is balanced, right? So the first option, the very first option is correct. Let's go through other options also. In the second option, it is given as the thorium is decaying to Pb. No, it is decaying to Ba. So I can directly put this is wrong because later is the most stable isotope. Later means we are referring to Pb here. According to this statement, the statement is correct, but not true for this reaction. Because comparing bismuth and lead nuclei is the most stable isotopes. Okay. So this is not going to be the correct answer in reference to this reaction. Okay. And the second one, the total of 5 alpha and 3 beta, no chance. 5 alpha will give you like not 16, it will give you 20. So 20 is not going to be your like balancing these two will get disturbed, right? So it is not going to be your answer. Next, I have thorium is decaying to bismuth. This is right. But later is the most stable isotope. No, the most stable isotope is lead. That is why more like you are producing some radioactive substance with lead wall better. So lead wall is the most stable isotope. So its nucleus is quite stable. So it won't undergo radioactive decay easily. So answer C and D are wrong. Answer is going to be A. Okay. So we have given with like multiple options. Ammonia contains 82.35 percentage nitrogen and 17.65 percentage hydrogen by mass. Okay, they mentioned mass and don't, okay, answer is also having mass. Don't ever do that. What they are mentioning it. What is law of conservation of mass? It is about the conservation. Let's say I have nitrogen and I have hydrogen is going to react to form NH3. So 3 moles of this and 2 moles of this. So the weight, if I measured here, the total weight and this total weight are going to be equal. So I can say in this reaction, the mass is conserved. There is no change in mass. But they are not referring to the conservation of mass. They are referring to the percentage, or they are referring to the fixed ratio, fixed percentage, I can say. So multiple proportion, no, this won't come, and reciprocal proportion, this will also not come. Multiple proportion involves multiple, like I have carbon dioxide and also I have carbon monoxide, but both of them will have carbon and oxygen. Now carbon and oxygen can combine into two different proportion, right? So this is called law of multiple proportion. So here they are not referring to two molecules, only one molecule. So it is going to be a fixed ratio. So I can select B, law of constant proportion, directly. Reciprocal proportion will involve three molecules. So it won't be an answer. Okay. Some rocket engine uses a mixture of hydrogen. So this is a hydrogen. Hydrazine, okay. N2H4, the way you can write like this also. It is getting converted into, anyway, we are using H2O2 also, right? It is getting converted into N2 and 4H2O. How much excess reactant? They are asking about the excess reactant. So you have to find the limiting reagent also. When 0.75, I can say this is going to be 0.75 mole or present hydrazine and 17 gram of H2O2. What is H2O2? Molar mass 2 into 1. Two hydrogens are there. Each hydrogen has a mass of 1. And 2 into 16. So what do I get? 32, 34, right? So I can write here 17 by 34. I can get 1 by 2. I can say 0.5 mole of H2O2 is reacting. And this and all will take it to later. Now, what is happening here? From the equation, I can say 2 mole of H2O2 require 1 mole of N2H4, right? Then what about, let's say I have H2O2 0.5 mole, right? So what about 0.5 mole? What about 1 mole of H2O2? First, you write that one. 1 mole of H2O2 require 1 by 2 mole of N2H4, right? And what about 0.5 mole of H2O2? required 1 by 2 into 0.5 mole of N2H4. So this is what is 1 by 2 into 0.5? It is going to be 1 by 4, or I can say 0.25. So I can say here 0.5 mole of H2O2 is going to react with 0.25 mole of N2H4. Yeah, it will react. Enough N2H4 is there now. So H2O2 is going to be your limiting reagent, like which is going to consume first. It is like you are eating dosa and chutney. Like which is going to consume first. If chutney is done, you will not eat dosa, like dry dosa, right? So chutney is going to be your limiting reagent, which determines how much you are going to eat, how much reaction is going to determine, how much going, like reaction is going to proceed. Okay, how much product is going to form. So now I can say 0.25 mole are reacted. So remaining N2H4, initially it was 0.75, now 0.25 are like reacted. So finally you have 0.5 moles of N2H4 remains in the solution, and there is no H2O2 is there to react. All the H2O2 is consumed. So what is the molar mass of N2O4? 2 nitrogen, 2 into 14 plus 4 hydrogen. So 28 plus 4, 32, right? So 32 gram per mole. So from this half mole, 1 mole is going to be 32 gram. Then 0.5 mole is going to be 16 gram. So answer is going to be 16 gram of NaCl4. This is not 0.5 mole, not this, no remaining, no remaining. Okay. The compound contains 40 percentage carbon and 6.67 percentage hydrogen. Okay, they are given in percentage. We have to find the empirical formula. So let's consider I have a 100 gram of compound. Anyway, they are giving in percentage. Now just convert into gram. So 100 gram of compound I have in my hand. And from that 100 gram, I have 40 gram of carbon. I have 6.67 gram of hydrogen. And I have 53.33 gram of oxygen. Now they are in mass. I need the count. How much, how many of them? Let's talk about carbon. If I divide it by its molar mass, I can find the mole of carbon. How many carbons are there, right? So this is 1 gram per mole. And this is oxygen, right? Oxygen will be around 16. Yeah, gram per mole. So I can get here like 40 by 12, 3.33. And here it is going to be same mole of carbon, mole of hydrogen, and here again 3.33. Now select the lowest value, these two, right? So it is like a ratio. Empirical formula, it is like a ratio to each atom. How many are there? So find the ratio divided by the lowest number. If you divide it, what you will get here? 1 carbon, 1 mole of carbon here, 2 mole of hydrogen, here 1 mole of oxygen. So the formula is going to be CH2O. So answer is going to be B. What is the volume of oxygen gas at STP is required to completely burn 44 gram of CO2? This question you have to be very careful, right? They are given as CO2. CO2, how many valence electron does carbon is having? 4 valence electron, right? And all 4 valence electron are lost to oxygen already. Two oxygens are there, each oxygen will get 2 electron from the carbon, so 2 oxygen will get 4 electron, right? So all 4 valence electron are lost to carbon. Then it can't be burnt, right? It can't get oxidized, right? CO2, no electron can be taken over this. What is burning? What is combustion? It is a reaction with oxygen, right? Oxygen cannot react with CO2 now to form some other compound. Like highest oxidation state that carbon can have is 4, right? So from that 4, it won't get increased beyond that. So answer is going to be 0. There is no amount of oxygen gas react with CO2. So choose the option as D. Which of the following transition corresponds to the highest energy photon emission in the hydrogen spectrum? Let's see. This is an atom. This is a nucleus of atom. This is the outer shell. So I'm going to write it like quite big also. Now see here, what is happening actually? In all this orbital, let us assume electrons are there. I am considering only one electron. If this electron is going to excite to next energy level, then it needs more energy because of more energy gap between energy levels, right? But see here, less energy graph, less energy gap. Here, more energy gap. From this, you can like 3 to 2. So where is 3? 1, 2, 3. 3 to 2. Another one is 2 to 1. 2 to 1. From here, you can eliminate 3 to 2 because they are asking about highest energy directly. Next, other two are C 4 to 2. It is like coming from 4 to 2. It is crossing one energy level. And 5 to 3. It is also crossing one energy level, right? So we have to calculate among this B, C, and D. A, you can leave it. How do you calculate? What is the energy level for one energy level? What is the formula to calculate it? It is going to be, anyway, it is hydrogen spectrum. So Ez is going to be 1. So I can say minus 13.6 divided by n square EV. And this gaps belongs to the difference between two energy level. So I can say del E is equal to 13.6 divided by n1 square minus 13.6 divided by n2 square. Here they are asking about the energy difference. You can just put the modulus so that whatever the value comes will be turned into be positive. So del E, calculate now. For B, it is 2 to 1. So del E is going to be 13.6 divided by n1 square. Instead here n1 is 2, right? So 2 square, or you can take the 13.6 outside. So you'll have 2 square minus 1 divided by 1 square, which is 1. So you will get the del E as 10.2 electron volt. And C, it is the energy level from 4 to 2. Then 2 point answer is del E. If you do the same thing, 13.6 divided by 1 by 4 square minus 1 by 2 square, you will get this value of 2.55 electron volt. For D, it is from 5 to 3. Del E is equal to 13.6 into 1 by 5 square minus 1 by 3 square. So finally you will get 0.97 eV. So which has the highest energy gap? That is B. So the electron coming from 2 to 1 will emit lot of light. Light of highest energy, you can say better. Photon of highest energy. Okay. The nucleus of an element contains 9 protons and its valency would be. Element contains 9 protons. That means the atomic number of element is 9, which belongs to fluorine, you can say better. What is the valency of fluorine? 1. Or you can write their electronic configuration 1s2, 2s2, 2p5, which means it has 2 shells. In that 2 shells, I have 2 electron over in the first main shell, and I have 5 electron in the 2 electron in the S subshell and 5 electron in the P subshell. 1, 2, 3, 4, 5, 7. So now 1 electron is required to gain the to attain the stable electronic configuration of neon, right? So it needs 1 electron so that it will become 2s2, 2p6, the valence shell. It will attain neon configuration, noble gas. So answer is going to be 1. The valency of element given is 1. Direct answer. Okay, this is a very good question. For a reversible reaction. So what is reversible reaction? This is a reversible reaction which is nothing but it is going forward and it is going backward also, which means I can say this is an equilibrium reaction. So at equilibrium, what will happen at equilibrium? The rate of forward reaction will be equal to the rate of backward reaction. So forward reaction has the rate constant of K1, backward reaction has the rate constant of K2. Before that, they are given the concentration first. We have to analyze the concentration first. A converted into B. So they are giving initial molar concentration. Initially, there was some A is there and B is also there. If X moles per liter of A, so X moles is reacted and X moles of A is reacted, which means X moles is decreased. And B is like A is converted into B now. So there is will be an increase in concentration of B plus X. So this is the equilibrium condition. At equilibrium, this is going to be the concentration. I can say this is the at equilibrium. This is initial case. Now put this. What is the rate Rate is always going to be directly proportional to the concentration of reactant. So I can put one constant because let's say you have two things. Let's assume this is a physical change, but still you can relate with chemical reaction. You opening it, these two part. One has more concentration, it will come faster. One has less like less amount, it will come slow, right? So rate is directly proportional to the concentration that is reactant is having, more or less. So rate is directly proportional to K into reactant concentration. This is the constant that we used, is rate constant. Now for forward, rate of forward reaction, K1 into A is the reactant, right? Rate of backward reaction, K2, and the reactant is B, right? Because reaction is happening from this side to that side, right? So now they are equal. K1A will be equal to K2A at equilibrium, right? This is at equilibrium. Now, what is the concentration of A? A minus X. And what is the concentration of B? It is B plus X. Now, see, you need X, just isolate the X. I can say K1A minus K1X will be equal to K2B plus K2X. Just bring this X this side. So you will get K1 plus K2X. If you bring this side now, you will get K1A minus K2B. So what is the X? So X is going to be K1A minus K2B divided by K1 plus K2. So answer is going to be A. The four quantum numbers of the outermost electron of K, potassium. So I have a potassium which has an atomic number of 19. So I can write its electronic configuration 1s2, 2s2, 2p, 6. This is the neon configuration. Then 3s2, total 10 electron. Then now 12, 3p6, 18, and 1 electron will be in 4s orbital. This is the electronic configuration of K. And we are asked to find the outermost quantum number of this 4s. So n is equal to 4, directly you can write. So you can eliminate A and D. Then it is an s orbital. What is the L value for SPDF? S orbital doesn't have any node, so 0. L value corresponds to node. And p orbital has one node, 2, 3. So S is 0. Then L value 0. If L value is 0, M is also going to be 0. It is minus L2 plus L. There is no minus, there is no plus. So only 0. So answer is going to be B. Yes, doesn't matter. Plus or minus 1 by 2. Okay. A cricket ball of 0.5 kg is moving with a velocity of 100 meter per second. So I have a cricket ball. This weighs 0.5 kg and its velocity is 100 meter per second. The wavelength associated its motion. So whenever they are talking about mass and velocity, what term has to be in your mind? Momentum, right? And momentum and wavelength, if you are relating, what term you should know? De Broglie wavelength, De Broglie dual nature. So De Broglie wavelength, what is the formula of De Broglie? Lambda, which is nothing but wavelength, will be equal to h, which is a Planck constant divided by mass into velocity, right? Just put it directly. Lambda is equal to, what is the value of h? 6.626 into 10 power minus 34 joule per second. And what is the value of m? 0.5 kg. You don't have to convert the kg, it is already in SI unit. So into velocity 100 meter per second. So these two will get cancelled. And the final thing you will get is, anyway, 0.5 is 1 by 2 now. You just multiply this 2 here directly so that it is, you can calculate very, very fast. Only meter will depend. 2 into 6 point. So it is like 13.252 into 10 power minus 34 meters, or you can write 1.3252 into 10 power minus 35 meter. So the answer is going to be C, 1.32 into 10 power minus 35 meter. Next, the strongest conjugate base. What is the conjugate base? Let's say I have an acid HCl. It is going to dissociate into H plus and Cl minus. What is an acid and what is a base? Base is a electron donor. Acid is a electron acceptor. Who will accept electron? Those who want electron, right? H plus want electron. So I can write it here. This is an acid, this is a base. Because it is having extra electron, if it is converting into HCl now, it has to give electron to H plus. But they are charged. So I can write, this is a conjugate acid of HCl. This one is going to be the conjugate base of HCl. So this is what they mean. Okay. If I have CH3COOH acid, it is going to dissociate into CH3COO minus and H plus. And this is a weak acid. So what happens is it won't dissociate further. So how do you measure the base, strongest base? It has to give electron easily, right? So this dissociation is limited, or I can say is low, and this dissociation is faster. What does it mean? It is fastly, it is donating to this H plus to form CH3OOH, COOH again. So I can say this is going to be the strong base donating faster, or you can remember this thing. If it is a strong acid and it will dissociate to produce weak conjugate base. If it is a weak acid and it will dissociate to produce strong conjugate base. And the other, like for strong base, let's say, it will have weak conjugate acid. For weak base, it will have strong conjugate acid. So if you remember this one, you can answer this very easily. So they are asking for conjugate base, strongest one. So you have to look for weakest acid. So this is from HCl. This is from, just add a H plus so that you know what acid it is. HNO2. So which is the weakest one? B, right? CH3 COO minus. So this is an acetic acid, which is a weak acid that you should know. So answer is going to be B. Okay, an acid with molecular formula of C7H6O3 forms three types of sodium salt. However, acid can form a salt by reacting with base. Let's say I have a strong base NaOH. So it is forming C7H5, one hydrogen is removed. Or you can put minus water from OH and H plus is joined to become a water. So C7H5O3Na, and again I am putting one NaOH minus H2O. It is forming C7H4O3Na2, and again I am using one NaOH and one water molecule, so that it is forming C7H3O3Na3. Now, what does it mean? It is forming three, like 1, 1 to 2, 2 to 3, and 3 to 4. So, it is forming three salts. These we call it as salts, okay? They are asking about the basicity. What is basicity? Number of replaceable H plus present in an acid. How many H plus are removed from this acid? From 6 to 3. So I can say 3 H plus are removed. So answer is going to be 3. pH of the solution containing 100 mg. Mg means milligram. Okay. In 250 ml of water, I have sodium hydroxide, which has a molecular formula of NaOH, right? So I have to calculate the pH. For pH, what I need? I can calculate through H plus ion concentration minus log of H plus ion, or I can calculate first pOH, so that again I will subtract it from 14. I will get pH, right? Here, what should I do? Here, they have given us sodium hydroxide, which is a base. We have to find first pOH using minus log of the concentration of base. So you need base concentration to find pOH. Concentration of OH is equal to what? It is nothing but molarity. Or I can say moles of OH minus divided by volume of solution in liter. That is already given. In liter, you can write it as 0.25 liter. What about the moles of OH minus? First, what about the moles of NaOH? How many NaOH are there? That much OH minus will also be there in solution, right? Strong base. It will dissociate completely to give OH minus ion. So moles of NaOH. How do I calculate given mass by molar mass? Given mass is 100 into 10 power minus 3 I can put, right? Milli gram divided by molar mass. Sodium hydroxide. Sodium has the molar mass of atomic mass of 23, and hydroxide OH. Oxygen is having 16 and this is 1. So we'll get 40. So 0, 0 I can get cancelled it, right? And the remaining part. So I can write 10 power minus 2 divided by 4 moles. So what is the concentration of OH minus ion? Moles is 10 power minus 2 by 4, and this is going to be 0.25. So what is 0.25? 1 by 4, right? So I can write this 1 by 4 here. So it will go up. So it will become into 4 divided by 4. 4 will get cancelled. So OH minus concentration is 0.01 molar. POH is equal to minus log of OH minus ion, which means minus log of 0.01, or I can write minus log of 10 power minus 2. So minus minus will become plus. So the POH is going to be 2, right? So POH is going to be 2. Then what is pH? pH plus POH is equal to 14. POH is 2. Then pH plus 2 is equal to 14. pH is equal to 12. That's all right. So answer is going to be A. Which of the following salt, when dissolved in water, will get hydrolyzed? What is the meaning of hydrolyzed? Hydro means water, lyzed means breaking. It is about breaking of water. So I have a water molecule here. Okay, it has a plus charge also, minus charge also, but partial dipole water vessel. Now I have ions. I have Na plus ion. What are the ions I have? I have K plus ion. I have NH4 plus ion. And I have again Na2 plus. Like Na, I can eliminate again, right? Okay. Na plus ion, will it able to take the OH minus ion from water to become NaOH? Will it have that capacity to do it? Let's take NaCl. It is a salt of NaOH and HCl, right? So NaOH will produce Na plus ion. It is a strong um, base. So Na plus is going to be weak acid. And what about this HCl? It is a strong acid. It will produce Cl minus ion, which is going to be a weak conjugate. You can use conjugate word. So Cl minus is a conjugate weak base. So weak acid. This is a weak acid. It can't get OH minus ion from water because it can't accept electron, right? Acid is a term used for compounds which are accepting electron. How, what is the ability of a ion to accept the pair of electrons? That is called acid, right? So this Na being a weak acid, it can't get electron from water. Same thing will goes for K also, because KOH is a strong base and HCl is a strong acid. Cl minus, it is already, we told, it is a weak base. It can't accept H plus. Cl minus cannot abstract H plus from water molecule. So water molecule cannot be cleaved, right? But what about NH4Cl? NH4OH and HCl. HCl cannot do. But what about NH4OH? This is a weak base, right? This weak base produce strong conjugate acid, right? Which is nothing but NH4 plus. This NH4 plus is being strong and it will able to cleave the water molecule easily. So I can say the only ion that can undergo hydrolysis here, it is NH4 plus ion. So answer is going to be B. The pH of a solution is 5. The hydroxyl ion, what is hydroxyl ion? hydroxyl or hydroxide ion. OH minus. I know pH is equal to minus log of H plus ion, or the H plus ion is equal to 10 power minus, it is a base 10, right? So 10 power minus of pH. I can write in both ways. For POH, it is the same thing. Again, if I want to find the concentration of OH minus ion, it is 10 power minus POH. And from pH, first find POH. From pH plus POH is equal to 14, right? At 25 degrees Celsius always. Okay. So pH is 5, POH we have to find 14. Then POH is equal to 9. Put it here. You will find the hydroxyl ion concentration, right? 10 power minus 9 molar. So answer is going to be 10 power minus 9 D. That's all.